हेलो स्टूडेंट्स, गुड मॉर्निंग। आप सबको मेरे यूट्यूब से गुड मॉर्निंग, गुड आफ्टरनून, गुड इवनिंग। आप कभी भी कब वीडियो देखते हैं तब उसके हिसाब से विश एक्सेप्ट कर लीजिए। तो आज के क्लास में हमने इलेक्ट्रिक फील्ड ड्यू टू डाइपोल का एक एक्सियल पोजीशन पे हम ऑलरेडी डिराइव किए हैं, एक डेरिवेशन। और इस क्लास में हमने इक्वेटोरियल पॉइंट पे, मतलब क्या है, इक्वेटोरियली बाइसेक्टिंग पॉइंट पे हम इलेक्ट्रिक फील्ड ड्यू टू द डाइपोल हम यहाँ पे फाइंड करेंगे बेटा। ओके, सो नाउ टुडे दैट हेडिंग will be like this. Okay, derive an expression derive an expression derive an expression derive an expression for electric field intensity electric field intensity due to at ले लो। ओके, at broad on position, broad on, this is also called as a equatorial position, equatorial bisecting position. Okay, so this will be the heading in examination. It is a long marks. It gives 4 or 5 marks. Okay, it is more important. ये जो है ना बहुत इम्पोर्टेंट डेरिवेशन है। बहुत बार जो है ना बोर्ड एग्जाम में पूछा गया है, सीबीएसई और स्टेट एग्जाम में भी आता है। ओके बेटा, सॉरी बेटा। तो यहाँ पे हमने क्या करना है, here take one dipole, this is negative. Okay, this point you take, this one negative charge, that is q negative, and point I am taking here a, and another charge plus q at point b, and these two are separated by this distance, and at the midpoint we are taking as a center of dipole. This is center of dipole. Okay, so from center of dipole to one charge, that I am taking length a, and this side also same, because O is a center of dipole. Okay, so now point we are taking at the equatorial position. Equatorial position is nothing but what? The line drawn perpendicular to the dipole. Okay, this point is called equatorial point, or we can say it is a broad on position. Okay, and distance of this point from the center of dipole is, I am taking here r. You can take x also. Okay beta, sorry. Okay, and this point distance from the each charge we can calculate by using right angle geometrical concept. Okay, so now we can say that here the electric field due to the negative charge always will be towards the charge. Okay, towards the charge, and electric field at this point due to positive charge will be away from the charge. So this is away from the charge. That I am taking as a, this is E1, this is E1, and this one is E2. Okay, this one is E2. Okay, and here this angle I am taking as a theta, and this angle is also taking as a theta. Okay, geometrically this angle will be the exterior angle. Therefore, according to the geometrical concept, exterior angle equals equal to sum of the two opposite angles, that is theta plus theta, 2 theta. This is 2 theta. Okay, here see, first of all this we can derive by using vector addition formula, as well as rectangular component formula also we can derive. Okay, both we can use it. I'll show you how to find it. Okay, first I'll take vector addition formula here. So now, so when one vector is along this side, another vector is this side, so resultant will be along this side. Okay, resultant will be along this side, in this direction, along the, that is in the direction of negative x-axis, in the direction of negative x-axis. Okay, so now simple way I'll show you, simple rectangle, by using rectangle component I'll draw it. Okay, this is a resultant electric field at the point P. Okay, beta. So now this is making one angle here theta. This is making an angle theta, and here this E1 is resolved into two component. One is along this direction. It is called horizontal component, E1 cos theta. Okay, E1 cos theta, and one is perpendicular to this line and along this side. This is, I am taking E1 sin theta. E1 sin theta. Okay. Similarly, this E2 also resolved into two component. E2 also resolved into two component. One is along this, because this angle is theta. Therefore, one will be the horizontal component, that is E2 cos theta, and perpendicular to that one is along this side. Okay, this will be the E2 sin theta, and here geometrically we can say perpendicular component of the each electric field are opposite in direction, so therefore they are cancelled. So they are cancelled, beta. Okay, so here only presence of the components are E1 cos theta, that is per horizontal component of E1, and E2 cos theta, horizontal component of E2. Only these two components are present, and they are vectorally added. They are vectorally added here. Okay, so now, so the resultant will be the resultant. So we can write here, we can write some explanation here regarding this figure. Okay, you should write in examination directly. If you write like this, means you won't get complete marks, so you have to explain that one. So how to explain, I will show you here. Okay, consider 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 a dipole, a dipole consider a dipole, that is AB of of charges, negative q and positive q, at negative q and positive q at A and B respectively, A and B respectively. Okay, respectively, and that is A plus A, that is 2A. Okay, will be the length of the dipole. length of the dipole. Okay, length of the dipole. And here O is what? O is center of dipole. Center of dipole. This is all we have to explain. Okay. Now let P be a point. P be a point. P be a point at a distance. At a distance, P be a point. P be a point on equatorial bisecting line or position, bisecting line at a distance at a distance r from the center of dipole. Okay, center of dipole. Okay, center of dipole. Center of dipole. Now what to do here? Next what to do? We have to write here electric field right here. E1, that is E1, this E1 is electric field electric field electric field intensity at P due to that is due to negative charge negative charge will be towards the charge okay. And E2 same you write here. E2 is electric field intensity at point P due to positive q charge. Okay, and it is away from the charge. Okay, away from the charge. Okay, away from the charge. Okay, next what to do here? These E1 and E2 are resolved into two rectangular two rectangular components such that such that is E cos theta E cos theta E cos theta E cos theta is what? E cos theta is horizontal component of E1 along negative x axis Okay, that we can take any some alphabetical direction also we can take here, negative x-axis. And E1 sin theta is perpendicular component, perpendicular 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 component of E1 along negative y-axis, negative y-axis. Okay beta, negative y-axis. Similarly we can write similarly like this. Okay, you know that. Okay, similarly e2 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 cos theta and e2 sin theta are two rectangular components, of E2. Okay, a rectangular component of E2. We know that here, since E1 sin theta and E2 sin theta, E2 sin theta, E2 sin theta are opposite opposite in direction, opposite in direction. These are opposite in direction. One is downward, one is upward, sir. Okay, opposite in direction. So therefore, they cancelled. They cancelled. Okay, they are cancelled. They are cancelled. They are cancelled here. Okay, they are cancelled here. Therefore, net electric field intensity. Therefore, net electric field intensity. Therefore, right here. Therefore, okay. Therefore, net electric field intensity. Electric field intensity. Intensity. Electric field intensity. Electric field intensity. Electric field intensity at P due to dipole will be sum of E1 cos theta and sum of E1 cos theta and E2 cos theta. E2 cos theta, that is net electric field that I am taking here. E net equal to E net equal to E net equal to E1 cos theta and E2 cos theta. E2 cos theta. So now, since since E1 equal to E2 equal to E, because they are equal in magnitude. They are equal in magnitude. Okay, they are equal in magnitude. They are equal in magnitude and direction also same. Equal in magnitude and direction also same. That we can write here. So now what to do here? Take vector concept also. You can add here vector. We can add here vector like this. Okay. Therefore, so these two are equal in magnitude. Therefore, this final equation becomes like this. Finally, these two terms we can add. Okay, we can add because algebraic addition and algebraic addition and vector additions are little quite different, because in algebraic addition we cannot consider their direction but in vector addition we should consider about the direction also. Okay, if the directions are opposite, we can say one is positive, other is negative. So here both are direction is same and magnitude also same, so therefore they are added. Okay, they are added. Net electric field intensity, that is E net equal to 2 E cos theta, 2 E cos theta. Okay, this you take equation 1, and by using that vector addition, electric field concept, that is uh, that we know that by electric field electric field electric field electric field electric field intensity electric field intensity at p will be what? E equal to that is we know that k q divided by the distance. Okay, what distance? Either you can take AP or BP. Now AP or BP we can take. I am taking here AP. Okay, square, AP square, we can take anyone, but here AP square, but here that is AP, no any assigned values are there, but we can take by using that what by using that rectangular component and rectangular triangle, right angle triangle formula, that is Pythagoras rule, that is equal to what? AP equal to what? AP equal to under square root, or we can take in bracket also, that is r square plus a square to the power 1 by 2. Okay, so therefore that above equation becomes, that is therefore E equal to k q divided by this AP square is nothing but what? AP square is nothing but what? That AP square is what? R square plus a square to the power 1 by 2, and this value substitute in equation here. Therefore net net electric field intensity, that is E net equal to k q divided by r square a square 1 by 2. Okay, 1 by 2, and here trigonometrically cos theta is what? Cos theta is equal to what? Cos theta is based by hypotenuse. This hypotenuse we got here, that is r square plus a square to the power 1 by 2. Both sides are same because they are isosceles triangle. It is a isosceles triangle. Therefore this AP and BP both are same beta. So same. So that value we can substitute here. Cos theta is equal to what? Cos theta is equal to a, that is a base, and hypotenuse is what? R square, and a square to the power 1 by 2. Okay, 1 by 2. So here we can say here this is a square, this is square, therefore here square root, that both are cancelled, therefore this term is cancelled. Okay, because here square it is there. Okay, where it is? Here it is square, it is this square, and this 1 by 2 both are cancelled here, therefore this term becomes like this. Okay, that term substituting by this also cancelled here. Okay, this also cancelled. So now here we can see, by using index law, bases are same, bases are same, power should be added. Here 1, here 1 by 2, that equal to what? That equal to k q, k q, k q. Here 2 also is there, no? Here 2 also is there. So that 2 we can manipulate here. Instead of writing here, I am writing here 2, a. Okay, this bracket term we can substitute in place of that one. What is that? Here bases are same, means base r square, a square, and 1, 1 by 2. This becomes 3 by 2. So 3 by 2, 3 by 2 beta, 3 by 2, and here q, that is either charge into length of the dipole, is nothing but what? It is a what? It is what? It is vector, that is dipole moment. That is dipole moment is what? K, where k value also we can write. K is constant. K is what beta? K is a constant. That constant k equal to what? K equal to 1 by 4 pi epsilon naught for air or vacuum. Air or vacuum. Okay. So here this value becomes 1 by 4 pi epsilon naught, and this is a vector p, that is a dipole moment, dipole moment, dipole moment here, and this r square plus a square to the power 3 by 2. This will be the final equation, that is E net, E net equal to, E net equal to 1 by 4 pi epsilon naught p vector, that here we can to write it here what, that to show the vector concept we can take here I negative also, I negative. Okay, I negative, therefore this r square, a square, 3 by 2, 3 by 2, this minus we can write here, this minus we can write here. That minus direction shows only the direction which is in x-axis, negative x-axis, negative x-axis. This minus shows it is the resultant is along the negative x-axis, negative x-axis. So now one special case will be, we can consider here. Special case, special case is what? If already I said you that dipole is nothing but what? Two equal and opposite charges separated by small charge, a small distance, that is in micro and micro and nanometer, micro and nanometer. As comparing to this r, as comparing to this r, because here we can take one case, that is note we can write here, note or case we can write here, for short dipole, for short dipole, for short dipole, that is r is very larger than a. So therefore this implies what? A square tends to 0, a square tends to 0. So therefore in final equation we can neglect that one, that is a square. Therefore we can what? We can neglect this one. What to do here? We can neglect it. So therefore net electric field due to short dipole, net, okay, short, net we can write here, short, I am taking here S for short, or short dipole, electric field of short dipole is equal to what? 1 by 4 pi epsilon naught here, and direction is opposite here, minus I am taking here, and that is p vector I cap divided by p vector I cap divided by r, that is square and 3 by 2 These two cancel, these two cancel. Therefore final equation of short dipole will be, that is, E suffix s equal to minus 1 by 4 pi epsilon naught p vector and I cap divided by r to the power 3, and this will be the final equation for short dipole of net electric field at point P, or at equatorial position, and at equatorial position. So from this equation we can say that electric field, or at the on the on the what on the equatorial position will be what, cube root of the distance, 1 by, not cube root, 1 by cube of the distance. Okay, 1 by cube of the distance. It is here, uh, inverse square law cannot obey that law. Okay, we cannot apply here, see. Okay, this is the final equation for equatorial point. Okay, and you should be perfect in this derivation. If you are not understanding now at a time, single time means repeatedly watch this video, and you must be perfect in this derivation. In this derivation, steps very important. Okay, steps are very important. Okay, thank you. In next video, I'll derive that electric field intensity at any point of the dipole. Okay, bye.